Alright, so section 6 is dealing with how many arrangements we can have of things. The text provides us with some basic counting rules. Talks about the factorial symbol and just how it means we're looking at the product of the numbers as a decrease. We also have these permutations and combinations. Permutations is when the order is important. Combinations, the order is not important. And here's a formula if we have identical items to each other. So if we want to find the number of permutations, different ways things can appear. So this is a good page to look at, page 176. Let's look at a couple of the homework problems and see how these work out. So in number 3, a fan of a country music plans to make a custom CD with 14 of her 28 favorite songs. How many different combinations of 14 songs are possible? So how many different combinations of 14 songs? So it doesn't sound like the order is important. So I'm going to say that this is a combination, because as long as there's 14 songs on it, I'm okay. So I can do this on my calculator. I want to use a combinations. So there's 28 songs, and under math probability, I can go down to combinations, and I want to pick 14 of the songs. And that looks like a whole bunch of songs. So again, lots of different combinations. Is this practical? I would say absolutely not, because let me look at all my commas. So that's like 40 million different ways. But this is how some other basic calculators will have this NCR and NPR. So you can find these values very easily. Another one to look at is number 8. So a corporation must appoint a president, a chief executive officer, chief operating officer, and chief financial officer. So those are 4 different positions. And it also must appoint a planning committee of 5 different people. So there are 12 qualified candidates, and officers can also serve on the committee. How many different ways can we pick the officers? So there's officers, and we have 4 officers. And this one, okay, we have 12 people. And I'm going to go to probability. Is it a permutation or combination? Is the order that we pick these 4 people important? And I would say yes, because being president versus chief operating officer, you have different duties. So I would say permutation, and we were picking 4 of them. And the committee, I need 5 members. So if I'm on the committee, is the order at which I'm picked to be on the committee important? Since there's not any titles except that you're on the committee, I say this would be a combination. So again, 12 combination, and I'm picking 5. What's the probability of randomly selecting committee members and getting the 5 youngest of the qualified candidates? Well, there's really only one way to pick the 5 youngest. And so if we're doing a fraction, it'd be one way out of the 792 would give me a probability. So just some different ways that we can use combinations, permutations to help us find the probability of events.